Hello everyone, my name is David and another group member is Eric. We are here today to present you about biometric security in mobile platform. Here is our table of content. Please feel free to pause the video at any time if it's too fast. Biometric security is now at the fingertip of all mobile users as it is extremely convenient and produce high accuracy for identifying access and securing mobile devices from unauthorized personnel. This report aims to provide a better understanding on how biometric can facilitate the delivery of mobile security authentication. It will mainly cover morphological biometric security, which includes fingerprint, face, voice, and iris recognition. Also, it will discuss about the strengths and weaknesses of each method and illustrates the future development of mobile security, in particular Android platform. So what is biometric security? Biometric security, in other words, biometric authentication, is basically a security process that evaluates and match biometric features or characteristics of a user with the pre-registered dataset before permitting or denying access to a device. Biometric security is nothing new, and it has been used for identification purposes throughout history. The very first form of biometric authentication can be tracked back to ancient civilization where Chinese were the earliest culture known to have used footprints as a means of identification. In addition, ancient Greeks and Aztecs used physical characteristics such as scars and tattoos to identify slaves or to distinguish between tribes respectively. In early 20th century, it became widely adopted by law enforcement around the globe. For instance, FBI founded Identification Division, which then became the largest repository of fingerprint records in the world in 1924. Then the growth of computer technology in 1960s paved way for facial recognition. Between 1960s and 1990s, other methods were evolved like voice and iris recognition. Later in early 2000s, this is where biometric security became more well-favored and accessible to the public with the introduction of biometric authentication on mobile platform. In recent years, biometric security is being globally used across industries such as education, healthcare, finance, military, law enforcement, and immigration. Before we go any deeper into biometric techniques, let's first compare it with the traditional PIN and password security. PIN is a secret sequence of number, usually 4 to 6 digits, easily to remember and can be quickly entered. It is also easy to implement, but it's easy to crack via brute force or phishing attacks. Password, on the other hand, is a string or a combination of characters, including letters, numbers, and symbols, that is usually 8 to 12 characters long or could be longer. It is also convenient and fairly easy to type. However, it is still somewhat easy to guess, brute force, or phishing. Next, biometric security offers enhanced security features compared to the last two methods. User also no need to remember anything. It also provides high accuracy, scalability, auditability, faster authentication, and improved user experience. But the drawbacks are it is very costly to implement and there could be some privacy concern regarding data collection. Biometric security is classified into three categories such as morphological or physical, behavioral, and biological. This figure here shows some example of each type of biometrics. First of all, morphological biometric is a method that uses physical characteristics of a user such as shape, size, textures, appearance, or body parts to identify their identity. These methods include several techniques such as fingerprint, face, voice, and iris recognition. Fingerprint recognition is one of the biometric authentication methods that is widely and popularly used due to its high level of accuracy and convenience. This method involves capturing and analyzing an individual unique fingerprint pattern that make up of ridges and valley to create a user profile or biometric identification for authentication purposes. Fingerprint recognition process typically involves several steps such as image acquisition, pre-processing, features extraction, template creation, and matching. Fingerprint biometric uses several forms of scanner. Optical scanner captures and generates the digital image by using algorithms to look at the ridges and valley of the fingerprint and detect unique patterns where ridges and the valley ends or meet by analyzing the lightest or darkest area of the image and turning them into ones or zeros in binary and a unique user's identification to authenticate the access. Capacitive scanner uses a tiny capacitor array circuits to collect data by measuring the finger via human conductivity, creating an electrostatic field and create a digital image based on that, and records by an analog to digital converter, then later be analyzed for distinctive and unique attributes of the fingerprint. Ultrasound uses an ultrasonic transducer to transmit high frequency pulse of inaudible sound wave against the surface of the finger and penetrate through the skin, then bounce off the underlying bone structure back to the receiver, creating a very accurate 3D rendering of the finger. Thermal finger scanner is a method that uses heat to measure the difference of the temperature between ridges and valley and create an image of the fingerprint based on the contrast between the two. In early 2019, Samsung released its Galaxy S10 smartphone with an ultrasonic fingerprint sensor. However, shortly after the release, a British woman named Lisa Nelson discovered that her husband was able to access her phone with unregistered fingerprint through a third-party gel cover screen protection. This vulnerability involved 5 simple steps to reproduce if an attacker has physical access to the device, such as lock the device with authentication enabled, remove SIM card tray and insert SIM with PIN code setup, enter SIM code wrongly 3 times, then enter correct PAC code to set up new PIN. Then device can now be unlocked without authentication. This issue was caused by the dismiss function called by PAC reset component on the security screen stack, causing it to dismiss fingerprint security screen instead of PAC security screen and unlock the phone. Thus, any Android users with operating system version 10 to 13 should apply the November 7, 2022 update security to their device. Otherwise, they would still be vulnerable to this threat. Due to time limitation, for further video demonstration, please visit YouTube link shown on the slide.
The talk about face recognition technology has become increasingly popular in our daily lives. So it is used into the video indexing, security surveillance, and criminal justice system for identification and identification. The 3 key steps was shown in the slide. The major task of face recognition is to recognize or verify one or more people in the scene using a database of stored face images, such as for one-to-one matching verification or one-to-many matching identification. Face recognition can also be combined with other biometric technologies to improve the performance, and with the development of deep learning technologies, face recognition performance has significantly improved. However, face recognition is still facing some challenges, including variations in lighting, pose, age, facial expressions, and facial occlusion. This face data with certain occlusion will interfere with the feature matching between the database and the target image. As a result, the current facial recognition algorithms are often designed to ensure system robustness with maintaining computational efficiency. Research on face recognition can be categorized as a feature-based method, holistic matching method, and hybrid method. Among 3 of them, the holistic method, originating from statistics and artificial intelligence, has been widely used for their good performance in learning and testing on face image datasets. The common logic of face recognition system workflow is to put the face image into system and perform face detection and measurement. Features are then extracted using the feature extractor. Finally, the system compares extracted features with the face in the gallery to perform face matching. Here are 3 different ideas used to represent the face. Left one are the recognized faces under different lighting conditions. Using the classic active near-infrared face recognition system. Middle one is the feed-forward neural network. It traces feature and creates a low-dimensional representation of the face for the classifier to access for recognition and classification. Right one are using DeepSmap to translate the Unicode curvature of the human face into individual signatures to create a 3D sharp for each person, then uploaded to database to identification. This is a case study of a deepfake high-quality attack on the Samsung Galaxy S8 and S9, which highlight the performance of multiple digital authentication solutions during COVID-19 pandemic. The widespread use of video conferencing and social media provide attacker with a rich source of face image. In the case study, Carroll et al. Conduct the deepfake video against a fake recognition system. The target scenario is a remote authentication solution, which allowing an attacker to bypass challenge-based recognition detection. The attack involves an attacker modifying or replacing biometric samples passed between the sensors and treaters. Examples include the fraudulently injecting photo or video data into mobile application or replace the data stream captured by the camera in real time. As shown in the slide, the attacker puts on the victim face and performs activity detection. After the attacker connects to the camera of the mobile phone, he uses the deep learning module to quickly prepare the attacker video and replace the face of the targeted victim through the sprite control and according to the requirements of the active detection. The acquired video segments are injected into the local, and the server on the mobile phone is controlled through the CAN of the PC.
Voice recognition, also known as speech recognition, is a deep learning technique that used to identify, differentiate, and authenticate an individual's voice or speech. Voice recognition process involves several stages such as pre-processing, features extraction, acoustic modeling, lexicon, and language modeling. Speaker recognition is a technique that analyzes various characteristics of an input speech or voice, including tone, pitch, pause, speed, and accent, to verify the speaker's identity. Voice recognition approach can be divided into two classes. Template matching requires a trained dataset recorded by the user, such as repeating the word or phrase several times into a microphone. The program will compute a statistical average sample, then store it in a data structure before it can be used to verify who they claim to be. As the user speaks a word or a phrase into a microphone, an analog audio is captured and converted into a digital signal or electrical signal via an analog to digital converter and store it in a memory for pattern matching with the database. Also, the recognition accuracy of this method can be over 95%. Features analysis, on the other hand, is a technique in which it processes voice input using Fourier transforms or LPC and attempts to find similar characteristics of expected input and actual digitized voice input. It does not require a user to repeat a specific word or phrases. Instead, it can compare the user's voice in real time to a pre-recorded sample or template to verify their identity. However, it has proven to be slightly less accurate than the first approach, with a rate between 90 to 95% due to some hurdles such as accent, speed, pitch, volume, and inflection. Security researchers at AVG has conducted an experiment that requires users to recite voice commands to launch Google Now and send messages to third parties. The experimental was successful, allowing them to be able to hack into Google Now voice system and then used the recited voice to gain access and send out commands. Operating system level attack is an approach that uses malware to exploit vulnerabilities of the operating system and collect users' voice, then self-trigger to perform a self-replay attack as a background service. Meanwhile, hardware-level attack uses a synthetic non-speech analog that is carefully designed based on hardware characteristics instead of human voice. This signal is inaudible but can be converted by hardware into a legitimate digital speech signal to trigger voice command.
Iris pattern are a reliable virtual identification method that can determine an individual's identity in real time via mobile platforms. With a very high level of convenience, those allowing identification tasks to be performed in large database with surprisingly high accuracy. So why is the iris pattern reliable? The human face is an active three-dimensional object whose image varies according to the angle of segregation, lighting, and age. For example, even the best algorithm performance recognitions on image a year apart with the error rate of 43% to 50%. Iris is an internal organ of the eye. It is well protected and insensitive to light angles, where the position of the eye and unique annular shape and complex pattern of the iris facilitate the creation of the standard iris representations and the isolation and the recording of the multiple unique features. So iris recognition can use the position of the eye and its unique annular shape, as well as the complex pattern of the iris, to create the unique iris present for each individual and can be highly invariant. Iris recognition system involve acquisition, pre-processing, segmentation, feature extraction, and matching. It will be introduced in next slide. Acquisition means using an image system to capture images that have a number of pixels within the radius or diameter of the iris. Pre-processing means some areas images are out of focus and blurred for various reasons such as movement. When captured, it needs to deep load. Segmentation means the iris acquisition process captures information about the immediate area of the eye and requires the use of virtual processing algorithm to enhance some features of the iris and sclera to segment those eyes from other areas. The bottom figures are the new method to detect and model the shape of the purer boundary and the iris outer boundary to define a more flexible and general coordinate system based on these shapes to improve the performance of iris recognition. Face extraction, getting various features for the extraction of the iris information in the improved local feature orientation method is used to the image on the right, named sparse representations. The purpose is to solve the problem that the traditional near-infrared system need to be close to the device to collect the distance. The matching means that represent the local features of every texture patterns. The features are segmented and extracted using non-layer normalization to matching these features from the retrieved quantity set. Before discussing the case study, we need to know that almost all commercial eye recognition sensors use near-infrared to capture eye images. Under near-infrared illumination, the melanin of the eye appears lighter in color and shows a range of iris texture. Then the algorithm can identify those features. However, iris recognition systems are easy to spoofing by contact lenses. It can alter the texture of the eye in the visible and near-infrared spectrum, confusing the natural iris pattern and hiding the real pattern. Therefore, individuals may be able to impersonate others by wearing contact lenses with a specific human iris texture. So here is a case study. A team of hackers using fake eyes to spoof the Galaxy S8 iris recognition system. Even less than a month after it global launched. The iris photo was taken with a digital camera in the infrared mode, and then printed and used with contact lenses of the pre-procurator to spoofing the sensor. The processing are shown as the slide. So this exposes that iris recognition is still a system with some drawbacks, although it has the highest recognition accuracy when it works properly.
In summary, this table concludes our findings and illustrates a comparison of some components between the four techniques of morphological biometric security in Android mobile platform. Fingerprint recognition is still the most preferred method used nowadays. However, iris recognition could be the future norm if researchers could bring the false negative or false acceptance rate down to almost near 0%, lower than the current fingerprint rate. Behavioral biometric is another form of biometric security that uses unique behavioral patterns. For instance, gait analysis is another type of behavioral biometric that involves analyzing a person's walking style. This method is most commonly used by law enforcement and border security, but also currently being explored as a potential authentication method for smartphones. Other potential use case for this method is to detect fraudulent behavior when logging into mobile banking or sensitive data. The main advantage of this method is that it can detect sudden changes in human behavior in real time to find any fraudulent activities. However, a major drawback for this security is that it can be very difficult to implement accurately. This is due to various affected factors, such as user behavior changes themselves or users with similar patterns of actions, making it harder for the system to precisely tell the difference between them.
Biological biometrics is a method that uses traces at a genetic and molecular level, including features like DNA and blood. This DNA backbone-based secretness allows it to carry a very distinctive biological information of an individual, so that the DNA recognition is usually used to identification rather than modification. So far, the development of DNA biometrics has been slow. It has several problems. One is that the DNA analysis has not been fully automatic, which is relatively slow compared to other biometrics. Second, since it requires sampling from the body, so it is invasive. In addition, the discussion of the privacy and security issues also limited the widespread of the DNA identification because DNA contains information about race, parentage, and medical conditions. For conclusion, each biometric security technique has its own advantage and disadvantage in terms of features, accuracy, difficulty level of implementation, acceptance and rejection rates, as well as the processing stage and algorithms. For instance, while fingerprint is widely used and provides the highest accuracy, it can be vulnerable to such attacks like the fingerprint spoofing, for the face recognition is also another popular method, but the accuracy can be affected by factors such as lighting and facial change due to the aging. In addition, voice recognition can be vulnerable to synthetic non-speech analyzed signal attacks. Lastly, iris recognition provides highest accuracy rate but requires specialized hardware, which could be costly and very difficult to implement. So all in all, the existing spatial and fingerprint recognition systems are secure enough for the general people, although they have some drawbacks, but in terms of easy use and security, they've achieved a balance suitable for data use. This is the end of our presentation. Thank you for watching.